Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Connected devices bring computing and internet capabilities into homes, vehicles, workplaces, and healthcare environments. These devices extend traditional technology use cases into everyday life. In the CompTIA Tech Plus exam FC0-U71, they fall under the larger category known as the Internet of Things, or IoT. Connected devices offer automation, remote access, data collection, and communication services. On the exam, you may be tested on their categories, functions, and potential risks. Smart home systems use internet-connected hardware to automate or control features within the home. These systems can be managed through mobile applications, voice assistants, or pre-programmed automation routines. A typical smart home setup includes a central hub, sensors, wireless communication protocols, and cloud-based platforms. Devices range from simple, single-function lighting controls to full-scale security and climate control systems. Smart thermostats are a key example of environmental control devices. They monitor and adjust home temperatures based on schedules, user preferences, or detected presence. These devices can help reduce energy consumption and costs, and they integrate easily with larger smart home platforms. Some use geofencing, adjusting temperature settings automatically when you leave or return. Communication methods include Wi-Fi, Zigbee, and Z-Wave. Smart door locks and entry systems provide keyless access through numeric codes, smartphone applications, or biometric authentication such as fingerprint scanners. Many allow temporary codes for guests or delivery personnel. They can integrate with voice assistants or broader security systems. From a security perspective, encryption, timely firmware updates, and strong physical construction are essential. Video doorbells and intercoms combine cameras, microphones, and network connectivity to provide remote visual identification of visitors. They allow you to see and communicate with visitors via a mobile device, even when away from home. Cloud storage features let you review recorded video and receive motion-activated alerts. For reliability, these devices require a stable internet connection, secure mounting, and consistent firmware updates. Home assistants with voice control, such as Amazon Alexa or Google Assistant, use wake words, microphones, and natural language processing to receive and interpret commands. These devices can play music, answer questions, control other connected devices, and initiate automation sequences. While convenient, they raise privacy concerns because of their constant listening capability and potential data sharing with third parties. Smart home security systems combine multiple components, such as motion sensors, window and door contacts, surveillance cameras, and audible alarms, into an integrated monitoring solution. These systems can trigger alerts, record events, or notify authorities. They are managed through control panels or mobile applications, and many rely on cloud integration for expanded functionality. Increased connectivity also increases potential exposure to security risks. IP cameras, or Internet Protocol cameras, are a common part of surveillance setups. They stream or record video over a network, and they may be used for security, pet monitoring, or elder care. Video storage can be local, using devices such as DVR or NVR systems, or cloud-based. Strong passwords, controlled port access, and careful network configuration are necessary to secure these devices. Streaming devices such as Roku, Fire TV, and Chromecast deliver media content over internet connections. Smart televisions often have built-in streaming platforms with their own application ecosystems. While convenient, these devices can consume significant bandwidth and may include privacy risks such as user tracking. Integration with voice assistants and mobile devices improves accessibility and ease of control. Wearables like fitness trackers and smartwatches monitor health and activity data, such as steps taken, heart rate, sleep quality, and oxygen saturation levels. These devices sync with mobile applications and cloud dashboards for storage and review. Some include GPS tracking, notifications, and the ability to run lightweight applications. Medical IoT devices include glucose monitors, heart rate sensors, and medication trackers designed for patient care. Some connect directly to healthcare providers or integrate with electronic health record systems, abbreviated as EHR. Security, reliability, and compliance with healthcare privacy laws, such as HIPAA, are critical for these devices. Connected fitness and exercise equipment includes treadmills, stationary bikes, and strength training machines with network capabilities. These devices can stream workout content, log performance data, and sync with health platforms such as Peloton, Apple Fitness, or Garmin. They provide entertainment, structured training, and progress tracking, but they depend on stable connections and properly maintained user accounts. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Smart appliances are an expanding category in connected homes. Examples include smart refrigerators, ovens, washing machines, and dishwashers. These devices offer features such as remote control through a mobile application, notifications about task completion, and energy usage tracking. Some models can automatically reorder supplies or suggest recipes based on inventory. They connect through individual brand apps or centralized home platforms. While they improve convenience, they also introduce considerations such as firmware update management, compatibility with other systems, and potential security risks if left unpatched. Integration platforms and ecosystems are the coordination layer for many connected devices. Popular ecosystems include Apple HomeKit, Google Home, and Amazon Alexa. These platforms allow users to control multiple devices through a single interface and set up automation that spans different brands. The choice of platform affects device compatibility, the availability of certain features, and how devices behave together. Some ecosystems are closed, meaning they only support approved devices, while others are open and allow third-party integration. Understanding these differences helps with both deployment planning and troubleshooting. Connected devices rely on stable network connections to function effectively. Most connect via Wi-Fi, but some use Zigbee, Z-Wave, or Bluetooth for communication. The reliability of these devices depends on factors such as signal strength, interference from other electronics, and the available bandwidth in the environment. In larger homes or buildings with many connected devices, a mesh Wi-Fi system may be necessary to provide full coverage. Information technology professionals should understand these connectivity variables to ensure smooth performance after installation. The setup and configuration of connected devices is typically handled through a mobile application, often using Bluetooth for the initial pairing process. During setup, the user or technician may be prompted to install firmware updates, link the device to a user account, and grant necessary permissions. One critical step is changing any default usernames or passwords to prevent unauthorized access. A proper setup process improves stability, ensures intended performance, and strengthens security from the start. Security risks are a major concern with connected devices. Common vulnerabilities include open ports, outdated firmware, and unchanged default credentials. Attackers may target these devices to gain access to networks or collect sensitive data. Devices without encryption or regular patching are especially vulnerable. Security best practices include segmenting IoT devices on a separate network, disabling unused services, and enabling automatic updates when available. Privacy considerations are closely related to security concerns. Many connected devices collect personal or behavioral data and transmit it to cloud servers. Terms of service agreements may include clauses about data sharing with third parties or using the data for targeted advertising. Reviewing and adjusting privacy settings can help limit unnecessary data collection. Awareness of how and where data is stored gives users and administrators the ability to make informed decisions about the use of these devices. Remote management and cloud service dependence are standard in connected device ecosystems. Most devices use the vendor's cloud infrastructure to enable features such as voice control, remote monitoring, and automated updates. If the vendor's service experiences downtime, some device functions may degrade or stop working entirely. This reliance makes vendor stability, support policies, and service life cycles important factors when choosing devices. Whenever possible, having local control options as a backup is recommended. The device life cycle and ongoing support are also key considerations. Firmware and mobile application support vary greatly between manufacturers and even between product models from the same brand. Devices that no longer receive updates can become security liabilities or lose critical features. For this reason, IT staff and consumers alike should evaluate the vendor's history of software maintenance and responsiveness to security concerns before purchasing. Troubleshooting connected devices often involves addressing connectivity issues, failed application synchronization, or firmware bugs. Simple actions like restarting the device, applying the latest firmware update, or repairing it with its controlling application resolve many common problems. Some devices provide diagnostic information through LED indicators, log files, or status pages in the companion app. Effective troubleshooting requires both an understanding of the device's hardware capabilities and the network environment in which it operates. On the CompTIA Tech Plus exam, you may see questions that ask you to identify a connected device category by its function or by a described feature. Scenario-based questions might require you to choose the best connectivity protocol, recognize common setup steps, or identify potential security risks. You may also need to distinguish between consumer-grade IoT devices used in homes and professional-grade devices deployed in small offices or industrial settings. Information technology support for residential environments increasingly involves connected devices. Entry-level technicians may be called to assist with installing, configuring, or troubleshooting smart home systems. The same knowledge applies in small office environments that use consumer-grade devices for convenience and cost savings. Familiarity with common platforms, device types, and protocols gives technicians a competitive advantage and expands the range of services they can offer. Some key terms to review from this episode include Zigbee, Z-Wave, IP camera, smart assistant, wearable device, cloud dependency, and device lifecycle. Recognizing both the acronym and the plain language meaning of each term will improve both your exam performance and your ability to communicate effectively with colleagues and clients. Grouping these terms by category, such as security devices, environmental controls, or entertainment systems, can make them easier to remember. In the next episode, we will shift our focus to the internal components of computing devices. We will explore what is inside laptops, desktops, and workstations, including the central processing unit, random access memory, graphics processing unit, and motherboard. You will learn how each part functions, how they interact with each other, and how this knowledge applies to troubleshooting, upgrading, and evaluating performance. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.